So let's start. Good evening, everyone. GDSC Government Engineering College Thrissur, in collaboration with the Government Engineering College Wayanad, conducting a workshop Introduction to Machine Learning. This is our last day of the workshop. I know you are eagerly waiting for it. So let me invite our speaker, Nishant Roy, handle over the section.
Thank you for the introduction. So today we will going ahead with some of the demonstration. Uh, Initially, I will show you how the code is working, and then I will give it to you, and you can just run it on your local machine after the seminar, obviously. So starting with is my screen visible? You can chat. Okay. So moving ahead with that, there is just a basic of Python. I think everyone knows about that. So coming ahead with that, there is a data type in the Python named as numeric, which consists of integer, float, and complex number. Like you can just run it and see that 5 is considered as integer, 5.0 is considered as float, and uh, 2 plus 4j is considered as complex number, like imaginary numbers. Now there is also data type called Boolean, which is demonstrated as true and false. Like if you will run it, you can see one is considered as true and one is considered means both of them are considered as booleans. But if you will just type it as the small case true, it will not recognize because Python is case sensitive and uses the T capital true or F capital false as its default true and false. So moving ahead with that, there are some more data structures like sets. Set is a collection of any simple or similar kind of data uh, in a similar to a list pattern. Like if you can see the demonstration, we have just initialized a empty blank set by just setting by having a variable and assigning it with set and also with opening and closing bracket. And we can just print it out like simple variables. And moving ahead with that, we can just simply place some string of characters inside the set to convert it into uh, uh, distributed elements like that. uh, like if we will run it, you can see the I for I is distributed in FREOEY. Like it split the string into the initial characters for that. Like F is there, O is there, R is there, E is there, Y is there, and capital E is there. If there is a repetition, it will just omit the repetition part. Now moving ahead with that, you can see if we just enclose it in single double inverted commas, it will consider it as a single string and distribute it across the set part, the set in the list part. And now if we will go with the lower half where we have enclosed it in square brackets and each character has curly braces assigned to it, you can see it has a designated place in the set. Like there is a place for for and there is a place for I. So moving ahead with that, uh, in this we can see there is a creation of integer as well as string set. uh, what it does is it will convert the integer part into string and then create whole set of it. Like you can see, the one two integers has been converted into a string internally and then converted into a set of characters. These all are treated as characters right now. Now, some assessing elements of sets. Now, what we are trying to do here is we are trying to assess the particular element inside a set using a for loop or any kind of looping system. So, what we are currently doing is we are creating a set using these elements, and then we are just printing the raw set without any manipulation. Now what we will do is we will print individual elements using a for loop and iteration, which will go inside the set and print individual element one by one, uh, and then we can just show it like that. And also we can check certain element are present in that set using the in keyword. Now you can run and see there is the output right now below, where we have created a set of for and I, in which we have iterated and gone through individuals element, like that is for and that is I, and we have also checked is there three inside the set and it has written false. Now one more popular data type in Python, that is dictionary. In this, what we have done is we will assign a value with a key, like a lock and pad. The key is unique to that value. Like every value have a unique key. There can't be a duplicate key or multiple uh, key for similar name. Like there will be a key of one, and the whole dictionary can't have a repetition of one that mm, dictionary part. Now, initially we will just create an empty dictionary using curly braces. Curly braces are designed for dictionary to create a dictionary without using any keyword, just with the symbols you can describe a dictionary using the curly braces. This is a simple code for describing the empty dictionary. Now you always have to define a key for a value, but values doesn't need to be always having a means there is no need of key to always have a value. You can just also without a value can have a key, but key is the important part. Like without a name a person can't live, but a name can be there without the person. Like person may be long dead but the name will be there. So a name is a unique thing here, like the key here. Now if you will run it, you can see and there is a simple demonstration of how the dictionaries are printed. Now, moving ahead with that, we can also create mixed variable dictionaries, like mixed data type dictionaries. Like here, you can see a name assigned with a, string assigned with a string, and integer assigned with the integer. What the internal part is, uh, each integer will be converted to a string and treated as a string. So if we will run it, you can see the name is assigned to I is assigned to a name, and then 1, 2, 3, 4 that set of or list of integers are assigned to the one variable, one data type. Now moving ahead with the dictionary, there is also a dedicated keyword or dedicated method for describing a dictionary or dictionary man- making. That is DICD. So what it does is we will have to provide a set of uh, key and value pair, and it will convert it into dictionary without using the curly braces part. So here you can see it just simply converted the input string or input data types into a dictionary using the dit method. Now you can also create each item as a pair method. Like in this, what we are trying to do, we are just pairing these things in a simple list manner. Like it is paired item. These two will be always together in this dictionary, like that. So if you will run it, you can just see that, like you can just visualize that if we will call this particular element or the key, the other part will be also assigned to it. Now moving ahead with the assessing part of the dictionary, what we will do here is we will access each and individual value of dictionary using some iteration or using just calling it by the key. Like you can just here, what we are trying to do is we are calling uh, and key to get the value out of it. Like if you will access the name part here, name key here, for getting the for part. Also, you can just without using the square bracket, you can just use dot get to get the value of a particular key. But the key part is you have to know the name of the key, like what key is it. It is a three or a name or one, whatever it can be. You have to know the key to get the value. Like that, we can just run and get the value out of the key. Now, after the dictionary and the set, there is one more data type, that is sequence type, which is a whole set of, like, strings are also in the sequence type. List and tuples are also in the sequence type. So simple strings, what we understand with the simple strings are, these are the set of characters like ABCD or 28 alphabets, uh, and there are many more, etc. But mostly strings are defined as single or double quoted character enclosed within that. Like there should be single quote or double quote that is enclosing that set of characters to demonstrate it as a string. Like simply you can see here, this whole thing is converted into string. There is one more thing, this space part is also converted to string. If we will just paste a and then run again, you can see the space is also converted into string. Now, creating a string using double quotes. Single quotes are also there, or double quotes are also there. It is depending on, like here there is a single quote used inside, so we can't just enclose it in again inside a single quote. What will be there? There will be syntax error. Like this single quote will start here and end here, but the ending single quote is not having any ending or starting part, so it will be left alone. So rest of the elements from here to here will be considered out of the string part, and there will be syntax error due to that. So what we consider, if there is a single quote inside a string, so what we will do, we will enclose it in double quotes, like the case here. Still, it will consider it as a single simple string. You can run and see that it has considered it as a string. Now, also, if there are double quotes inside the string, so there are single quotes as well as double quotes. So what we do, we will use triple quotes, triple single quotes to enclose the whole string and convert it into a string and print it like that. If there is like a person, I am like this, here I am an analyst and I live in a world of data. So here what we have to do, data is also enclosed in double quotes, and there is single quote in IN. So what we have to do, we have to enclose whole this string in three quotes to convert it into a proper string for a Python data type to recognize it as a string. You can just run and see how to. Now, if you are using a triple single uh, uh, commas or hyphens to demonstrate a string, you can also skip the line and move in below line to create a kind of a string, multi-line string, and it will just show it like the simple multi-line string that you will expect it to do. Now, after the string part, we also have to access the particular string inside a whole, like it is string slicing. What we are trying to do here is we will take a string one, data scientist, and we will print it like a normal string. In the below part, what we are trying to do, we are accessing the individual element of that string by just demonstrating, by just using a square bracket. Inside that, we are trying to pass on the value, the place position, like the indexing of the string. Every string has an indexing starting from 0 and going up to the till the end part. Like the data scientist will be starting from 0, 1, 2, 3, 4. The space will also be counted: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Like that, it will be placed inside the Python. Now, what it does, there is also a positive indexing, there is also negative indexing. What in the negative indexing does, it will start with this side only, but show the last word of the string. Like if you will run it, the first thing is we will just uh, print the simple scientist. Now what we are trying to do is we are passing a zero inside the square bracket and getting the first element of the data scientist, that is D. And if we will just pass the negative one element, it will just show the last element of the data scientist. Like the positive indexing will be doing from 0, 1, 2, 3, 4, 5, 6, like that, and the negative indexing will be done from the right hand side to left hand side, like -1, -2, -3, so forth. So you can see the first element is easily accessible of the string, and the last element is also accessible. Now the one of the most used data structure, that is list. We can demonstrate it using square brackets. Here you can see, and we are just created as empty list right now. You can place any kind of data variable inside the a data type inside a list to convert it into a sequence of that same or different kind of data variables. Like here we have written I love football. The whole string is converted into a single element inside a list. You can just print it and see the single element of the list. Now what we have created is a sequence of string inside a list, which is an individual element inside that. Now also the list has indexing like 0, 1, 2, 3, and also the negative indexing. So what we are trying to here is we will create a list using I, for, and price, and then we will just index it using, then we will just access it using the indexing part, like the 0, we will pass 0, it will show the I. If we will pass to 2, it will show the price. Like that, we will just access the element using the indexing part. Now the below part is a multi-dimensional list, like, or we can say it as nested of list. Means there is a list inside a list. Here you can see there is a outer list. Inside that we have Madrid and Chesla, Chesla, and also United, like the football teams. The Madrid and Chesla is inside a individual list, which is also inside a bigger list outside of that. You can also see. But what here what will be happening if you will write as 0, it will show just in the first index element, this, that is Madrid and just Chelsea. So this both of them will be shown here. And if you want to see only the Madrid part, then you have to give 1 here again, sorry, 0 here again. 0 again to see only the first element of the list. So you have to use twice the square bracket to access inside the list again, then inside the second list. You can just undo it and you can see the initial output of that. Now accessing the element of the list. Initially we have done it. We are also giving it a separate section here. So we have just created a list of apple, mangoes, and bananas. Now what we are trying to do is we will be accessing the apples and bananas using the index of them, like 0 and 2. We can also use the negative indexing, like the -1 for bananas and -3 for apples. You can just see the output here. Now there is one more data type, that is tuple. What is the difference between a tuple and a list? Is just a simple that list can be mutable. Like if we have created a list of apple, mangoes, bananas, if in the later time of the programming we want to delete the bananas, we can do it, and if we want to replace it with some other fruit, we can do it. Now with tuples, these are not mutables. Like this can't be edited in the later half of the programming part. So if we have created a tuple, empty tuple right now, we can just use the parentheses, the opening and closing parentheses, to demonstrate the tuple. Now in the lower half, we have just created a tuple using two of the strings, like data and analytics, and you can just see the output. It can be shown as this parentheses and then the data, the strings inside. Now you can also convert a set of list or any kind set of strings, anything, using the tuple part, the tuple keyword, to convert it into a tuple. Like this code here, we have just created a list of 1 to 6 elements, and then we have just converted it into tuple using the tuple keyword. Now you can also use the simple tuple. Like the tuple keyword is used for converting any set of lists or variables into a tuple data type. You can just see the output. Now tuples can be of different types like integer tuple, string tuple, and variable tuple. These are variable tuples. What here it is demonstrating is a concatenation of the different tuples into a nested tuple, in which there is a tuple 1 and tuple 2 inside the uh, outer tuple. Now accessing element of the tuple, it is similar to the list part. Like you have to pass on the index of that particular tuple that we want to access, and it will just show the element of that. Like the 1 0 demonstrate the 1, -1 demonstrate the minus the 5, and -3 demonstrate the 3. Now string method, there are different type of string method or different string functions inside of Python that can be used for different purposes. Like uh, if you want to convert a string, like this simple I for an I can be converted using this code. Like the following output, you can see this string is simply converted into a all capital string. Like there is small y, it has converted into capital Y. Similar to dot upper, there is also a function dot lower, which will convert all the string into a lowercase. Similar to that, there is one more that is title. What it will do is it will convert the first element of the string or any element into uppercase, and the rest will be in the lowercase. And you can see the difference between the original strings and the converted strings. Now the important thing, that is slicing of strings in Python. Like if you have a string, like a strings, and if you want to slide it between different strings, like you can just pass the uh, three for slicing it into three parts, starting three characters starting from the first to the number that you have given it. Slice is a keyword used for slicing the string, and also you can give it in the three comma separated values. The first one will demonstrate the starting part, the second one will be demonstrating the ending part, the third one will be demonstrating the steps with which it will jump from 1 to 3 to 5, like that it will jump between that. So the first one, you can see the output, it is showing 8 AST. The second one, you can see what it has done. It has taken the first one, means it has left the first one and then gone to S, then left the T, then gone to R, then left the I, and the rest of that, because it was passing beyond the fifth place. Now similarly, there is Gita also done in the reverse indexing manner. Now you can also slice the string using the square bracket pattern, in which you have to pass the starting point and the ending point of which you want to slice the string. Uh, there are various fashions in which you can just use the start and stop part. You can only use the start part. You can also use only the stop part. You can also use simply the colon to copy the whole string, and you can also have step in that to have some increment in the copying part. Like below, you can use simple, like you, if you have passed 3 here, what it will do, it will just copy the string from this parent string till the third place, like 0 1 2 and 3, but the s is the last part is omitted in the Python programming. Similarly, you can see in the below half, like it will start from 1 go till the 5, but in the increment of 2, like it will start from 0, then sorry, 0 is omitted due to the one part, and it will start from 5, then skip to part, that is 1 and like 1 and E, Y in E, then it will go to S, then it will again skip to part and it will go out of the range of that 5, and so it will just print two elements. Similar to the negative indexing. And also, if you simply want to reverse a string, you can just pass the -1 here, remaining the start and stop. It will just reverse the whole string from right to left. Also, similar to that, there are some more list methods. Like if you want to, like you have created a list of elements including strings and integers, it can, if you want to append or add some more element to it, if you have to use append method, in which you have to pass the element inside it and it will just append it in the last position of the list, last part of the list. Similarly, you can also insert. What append does, it will always insert it at the last part of the list, and what insert does is it will insert it on the index that you have passed. If you have given 2, it will be placing it after the 0, 1 and 2 here. It will be placing the element. Similarly, you can also concatenate two list using extend. What extend will do, it will add this element in the back of that element. Like uh, there is 1 2 3, so it will add 1 2, after 1 2 3 it will add 2 3 4 5 here, adding list 2 to list 1. Now if we want to add list 1 to list 2, so we will just like take list 2 dot extend list 1. What it will do, it will add list 2 inside the list 1 part. Like you can see 2 3 4 5, then 1 2 3, then again it will be passing the 2 3 4 5, because the here the list 1 has been converted to this 1 2 3 4 2 3 4 5. So now it will just simply be appended in back of the list 2. Now you can just simply pass on the sum keyword to sum all the elements inside the list to give the sum of that. And also you can use count keyword to count the unique occurrence of 1 inside the list. Like if there is a key element 1 and it has been repeated 4 times, it will show the 4. Now also you can use the len part. What len does, it will count the element inside the list and give the number of elements. Like if you will do it like 1 2 3 4 5 6 7 8 9 10, so it will be giving us 10. But the index of the last element will not be the 10, it will be 10 minus 1, like 9, because it will be going as 0 1 2 3 4 5 6 7 8 9. So what len does, it will give index plus 1 of that list, the last element of the last index of the element plus 1. Also you can just print the index of the list, uh, element from the list using the index part, and using the minimum you can find the minimum of that index from the minimum of that element from the list. Like the 10 is the minimum in this list. And then also you can use pop to pop the last element of the list. Like if there is no input pass on from the in the inside the pop, the last element will be popped out of the list. And if you will pass the index like 3, so the third element from the list will be popped out. Then similar to pop, there is one more method, that is delete. What delete does, it will take an index and it will delete that part from the list. Like if you will pop, if you want to delete the 2.3, you can just pass the index 0 and it will just remove the 2.3 part from it. You can also copy a list using the function dot copy. What it will does, it will take the list or part of the list and copy it to the variable or any design part that you want to do. There is also similarly, there is a list slicing like string slicing. Uh, Here you also have to pass the original the start part, the end part, and the steps by which you want to slice the list. So here it was some of the basic fundamental that is required for the Python data types and Python manipulation. Now there are two more, but I want to just skip to the much more interesting part, that is the heart disease prediction using machine learning. Like nowadays, much more of our elderly people are encountering with some of the fatal diseases like heart attack and etc. So what this model will do, it will take a data set of the past patients, and it will uh, create a machine learning model out of it, which will be used to diagnose or used by the patient who have their report, and it will just pass the value to it, and he will it will just predict, is the person is the person having a risk of heart attack or not. Simple, very minimalistic. If you will just for demonstration, if you will just run this code right now, what it will do, it will just create a dialog box like that. Now for demonstration, I will be taking a value from here like that, and increase. So this was a data set from which we have trained this model. Now for, we will just take any random value like this one. We will input the value like 71 for age. 0, 0 means female, and CP is also 0. PPS is also 1, 1, 1, 2, 1, 1, 2, 149, 0, 1, 125, 0, 1.6, 1, 0, and 2. We'll press the credit button. It will show what is the likelihood that, like it has shown no heart heart disease, no heart disease. So we will just go here and see. It has shown us the target, that is 0, 1. One assigned, one means that there is no heart disease, any kind of heart attack or any kind of problem assigned to it. So like that you can see a demonstration. And now we will go jump back to the machine learning part, like what we are currently trying to do here. So any doubts in the previous one, like the Python fundamental of Python? Hello. Yes, no, anything. There will be some issue with my English part, so you can also say that there is some problem with my English. I will just try to be much more slow and be much more fluent. Any doubt, anything? Yes, no, you can just type in the chat box. Okay, then we'll just go ahead with that second heart disease prediction. So here what we are trying to first do is we will import a library that is pandas, which is used for calling different kind of data sets and manipulating it and, and doing some kind of pre-processing inside of that. So we'll just call the pandas and we will just read out the CSV file, comma separated file of the hard disk that we have just shown here. This hard disk part, this one, this is the data set comprising of here about 125 1025 patient data, and it will just train a model out of it. So we will call the data set. And now what we are trying to do is we are just using a built-in function in the pandas that is null to just see is there any null value inside of the data set, and also giving us some of that, like how many of null value are there in the age, sex, or CP or FPS category of the data set. But just simply running this code, you will just get the some that there is no null value currently in the data set. Now here what we are trying to do is we will take care of the duplicate values inside the data set. Here we are taking care of the missing value. Here we will going to take care of the duplicate values here. So in there is a duplicate function inside the pandas which we are calling here to get any duplicate values inside the data set or the CSV file which we have imported, and any keyword we will just give true and false, convert it to true and false to get a know-how of is there a duplicate value, yes or no, like that. If you will just run it and print the output, you can see the true is printed out, like there are some duplicate values here. So in the next step, what we were going to do, we will also call one more built-in function that is drop duplicates. What it will do is it will drop the duplicate values from the dataset, and by calling it, and also now by trying to do the upper part, that is trying to deduce is there any duplicate value inside the dataset, we will be going to get a false, like there is no duplicate value right now. Now, hence we have taken care of the duplicate values along with the missing values, and also imported the data set. Now, what we are going to do is we are going to do some kind of data processing. In like there are, if you will go to the hard prediction, and inside the hard CSV file, Here you can see some of the variables are in the form of 0, 1, 2, like the FPS, FBS, and the sex and CP. And some of the variables have distinct values like 168, 155, etc. So what we are going to do is we will convert these kind of data set or data values into constant and continuous. So what here we are trying to do is we will create two of the empty list, and using for loop, what we are going to do is we will go inside individual column of the data set, like the vertical parts, the column, and using the data dot columns. And what we are going to do is we will check are there none values or no or not. So and unique means it will show the unique values inside the column of the data set. And if you want to access individual element of the column, we have to go like data square column. In it will check until the unique value, that is the number of unique values inside that data set, exceeded, that is equal or less than 10. If it is equal or less than 10, what it will do, it will append it inside the continuous data set. Like here, and if it is more than 10, then it will just um, sorry, if the values are less than 10, it will append in the continuous data set. And if it is more than 10, it will append in the, sorry, it is the continuous in the category. It will append in the category data set, and it will append in the continuous data set. Here you can see after running this code, it just simply uh, converted the sex that is here. You can correlate it with like sex has 1 and 0, like male and female. So these are categorical data. And like if we go inside the data set again and see the age part, age has a whole range of numbers from 52 to anywhere near 71 also. So These are continuous data set. Now, after distinguishing the data types and into continuous and continuous and categorical, what we are trying to do is we will do encoding in the uh, continuous categorical data sets. And here what we have done, we have called the CP part of the data set. Here, if you can go outside, and this column that is CP, we have called it and try to find out the unique parts, the uniqueness of the CP. And here we have got about four kinds of unique data set here. So what we are trying to do is, first of all, we will remove the sex and target, because target assigned the nature of the patient. Is he facing a heart attack or not? And sex is like it is distributed into 0 and 1, so we doesn't require to do some more encoding in that. So after that, we will just print the first head of the file, first five elements of the uh, data set using the head function. And inside this category, we have just removed the sex part and the target part, because we don't want to know is the patient heart have a heart attack or not. And also in this encoding process, and also we doesn't want to encode the sex because it has the two variables, that is the male and female. We doesn't want to do more of the encoding part. What encoding does is it will convert the um, the values like 0 1 2 3 into uh, 0 1 0 0 and 0 0 1, like that it will convert the values of the data set. Now if you can see here, and what we call it is as dummy variables, because we have created it to make the machine easy to understand. So after removing the sex and target, we just use the pandas built-in function, that is get dummies, and pass the data frame along with the columns that we want to uh, make into encoded values. So here you can see, after doing that, we have encoded the variables using like 0 0 1 0 0 1 1 0, like that we have encoded it. Now again, if you will print the head, you can just see it has been encoded into the like 0 0 1, like here you can see the encoding part. Now here what we are trying to do, we will scale the features out of it for the machine learning model to learn and extract the insight from that. So there is a uh, well-known library of Python, that is sklearn, for implementing various kind of machine learning algorithm without writing the individual code for that. Just importing the model and just using the built-in function will be helpful for us to create some of the uh, models without going in depth of the machine learning algos. So from sklearn, we are calling a subcategory, sub library, that is pre-processing, and from that we are calling a standard scaler. What scaling it will do, it will convert the data frame into different categories for further for the use by the machine learning part. So here, after calling the standard scaler into a variable, we will just pass the individual constant values of the data, and we will just fit it or transform it into a scale that can be used by the machine. Like here is here all the values are ranging from 125 to various um, values, like it can be going all the way to 165 or something like that, 300 also, and here also the values are going ranging from 300 400. So machine doesn't know what is 300, what is 400. What we are doing here is we will convert those extreme values into a value ranging from -1 to 1. Like here you can see it is converted into the like 0 -0.37 to +0.9, like that we have converted it into a range that can be used by the machine to understand what is the correlation, or what is the relation of that variable or value. Now if we will print the head, you can see it has sorry, I have not done that in SQL and standard library. Then you can just see it has converted into a range. Now splitting the data set for test, like we have earlier in the first lecture, we have talked about how the whole raw data set are converted into a section in machine learning of positive and negative, sorry, in the ratio of 80/20, for 80 to train the model and 20 to test the model to get the accuracy of that model. So here what we are trying to do is, first we will drop the target part from the model, and we will just use the target for the y part. Y will be the testing part, and x will be the for training part. Now again we will use the sklearn model, and we will use the train test split function of that, and split the data into four different categories: x train, x test, y train, test. Now if you will just run the y test part, sorry, I cannot do this. You can see there is the value assigned to it along with 0 and 1, showing that uh, is it having a heart attack or not. Now after that we will be using one of the machine learning model, that is logistic regression. what it does, it will be using a regression model to find the uh, unknown point in the line of the data that we have provided. So after the pre-processed data set that we have created, we will again import the site sklearn. From there, we will import the some of the linear models, amongst which there is lossy regression model, and in that we will just pass on the X train and Y train part. X train is the dependencies, and Y train is the resultant output for the training part. Now, up- now after training, we will use the test function, test data set, to get a result of what the train model is able to predict from. Now, again, from the sklearn, there is one more model for getting the accuracy score or the accuracy of that model, which we have created. Here, after calling that and passing the y test and y predict values, what it does, it will, if we just insert a cell here and just print y test, you can see uh, like that. And also, if we insert a cell below that, and pass y underscore predict and run it. It is an array of list similar to that. If you can see, the first one is one. Here also, first one is one. The second one is zero. Here also, second one is zero. Third one is also zero. Here also, third one is also zero. But the fourth one is one, and here the fourth one is zero. The similar kind of error can be all throughout the data set, which cumulatively give us a score of 78.6% of this logistic regression model. Similarly, we will go with one more support vector classifier, which uses support vector machine to to do the prediction part. There's one more kind of machine learning part. So again, we will import the sklearn. From here, we are using SVM module, and the similar part, like we will try to fit the X train and Y train inside this SVM pre-trained model and create a prediction model out of it. Again, we will do the prediction part using text test part, and we will try to get an accuracy score from that, which is slightly better than the logistic regression. These all that logistic regression and SPC, K nearest neighbor, and etc. are some of the machine learning models. Here we are just seeing the implementation, but if we will Google it and get the backside logic of this, just this small code, it will be a huge brain pain like that. So we are not going in that part. We are just having a simpler execution of codes, and we will just compare it at the last, that which one is better for this kind of data sets. So again, going in the fitting and prediction part, we have just got an accuracy of 80% somewhat. Now there is one more classified as k nearest neighbor. We will just run it and get an accuracy score. So what we are trying to do is we are running the heart disease prediction data set, the process data set, into various machine learning model to see which one gives the highest accuracy amongst all. So we have gone with the logical regression. We have gone with the simple support vector classifier. We have also gone with the k neighbor classifier, k nearest neighbor classifier, and after that we will try to get the score. K nearest neighbor has a range from 1 to 40. What it does, it has a means what it will do amongst the data points cluster above in the xy plane. What it will do is it will create clustering or associations between different points, and each clustering, each kind of clustering ranging from one dot point to 40 points of clustering will give some different kind of accuracy result. So here are some of the result. You can see the score of the k nearest neighbor using this neighbor classifying parameter ranging from 1 to 40. We are getting 40 different accuracy chart accuracy point. Now what here we have done is imported an visualization module of Python, that is matplotlib, and in that we have passed on the score and tried to get a visualization of the different accuracy points, like which k value or which clustering value is much more accurate in this sample size. You can see after 0, if we go to 1, it is going near about 80. So my saying this, we come to a conclusion like the initial 1 and 2 are giving a greater uh, kind of accuracy relative to the rest k values. So we will just take a value of 2, and again we will try to train, and we are getting a suitable 80% of accuracy from the KNN. Now there are one more non-linear machine learning algorithm. Uh, Again, we are just going to give the CSV file. Here the requirement of the processing is not that much like the KNN, SVM, and the logistic regression. We are just dropping the duplicates and the null value, dropping the null value is not that much required in this, and also the uh, scaling and the encoding is not that much required. So we are again calling the hard CSV and just dropping the duplicates and also dropping the target part and just splitting it. You can just see, just split it. Uh, and just that we have just split it and created a test train model out of it. And also we have used one more model that is decision tree. This is a means there are two segments of the linear regression. Sorry, machine learning part. These all are the linear part, linear machine learning models. So it requires a pre-processed and properly like we have to drop the null parts, we have to drop the duplicate parts, we have to do a scaling, and we have to also do a encoding before passing the data into the model. So they are very much picky about the data that we are going to pass develop. And if we are using a non-linear model, they doesn't require that much of pre-processing and that much of scaling and encoding. It can just use the drop. We just have to drop the duplicate parts and just pass on it into the models. Like the one first model of this is decision tree classifier. Uh, Now if we will just run it using the previous test trend that splitting that we have done here, it is giving a near about the score of 78%. And there's one more similar kind of decision tree kind of classifier, that is random forest classifier. We are just giving the initial the test part which we have done here to different of the non-linear models to get a accuracy score of that. So in the random forest, we are just getting the highest till now, that is 85%. And again going with one more, that is gradient boosting subclassifier. We are getting near about 80% of the accuracy. Finally, what we are is we are converting all the accuracy score that we've got uh, into a pandas data form, data frame. So these are some of the initials of the machine learning models which we have learned, which we have tried. That is logistic regression, support vector machine, k nearest neighbor. These all are linear machine learning classifier, and the later hub, that is decision tree, random forest, and gradient boosting classifier. These all are linear uh, machine learning models. Now, if we print the final, sorry, if you print the final uh, chart of what all models we have run and what all HSS score we have got, here you can see different parameters, and the random forest has given us the most accurate result. Now we will again import one more visualization model of Python, that is Seaborn, which is used for visualizing in a vector format. So in Seaborn, we are using bar plot to plot the models along with the accuracy score. Here you can see the most most accurate is random forest right now here with an accuracy score of 83%. Now we will use the random forest model to train for the final model which we are going to use for the machine learning this model. So again we will drop the target part from the data frame and use the random forest to train our model. Now we will again use the new data outside of the raw data that we have, that initial Excel file, and pass it inside the mm, model which we have trained to get uh, a random accuracy of that. These are some of the parameters, and passing it inside the new data and passing it inside the model which we have created, which is giving us no disease assigned with the value 0. Here we can just correlate 0 with no disease, like the similar in this Excel. Zeros are mostly representing the no disease part, and one is representing the disease part. Here you can see that, like if 0, it's no disease. Now there's one more library in Python, that is joblib. What joblib does is it will help us to store the trained model. Like if we want to run the model again and again, the Python programming again and again, we just doesn't need to train the do with the above part repeatedly to get a model to test it. We will just pickle, or we will just freeze the model that we have currently created, and use it again and again to get the predicted outputs. So here we will input the job and also we will just dump the model, that hard disease prediction model, and we will again test if the frozen model is in accurate state or not. We'll just load it, and again we will just give a new data to predict it, and it will give us the output array 0 means no disease. And if we will again print the tail or the lower half of the models, you can see the data set, just to know what all kinds of more data we have here. Now for the final part, we will create a GI out of it to be user friendly, that so that the user can use it and uh, get their result. So here what we are doing is we will import one more model of the Python, that is Tinker. What Tinker does is help us to create a GUI out of it. GUI using simple Python codes, which can be run on any platform having a Python and Tinker library. So we will just simply import a Tinker and all the function inside that by using import asterisk and also import joblib. Now what here we are doing is we are creating fields or data fields where we will import the values. They are totally in total there are 13 values, uh, different integer types. From here, all the values will be fed inside the uh, model, and we will also have to recall the frozen model which we have made earlier in this stage, and we will just get the result out of the model that we have created. And if the result is equal to 0, that is no disease, it will just print it out in the no disease part. And if there is something else other than 0, it will just give possibility of heart disease. What here the dot get function is doing, it is getting the value out of the form that we will create in the Tinker, and also this grid function is helping to place this no heart attack label inside the GUI in the lower half of the GUI. Now here we are just calling the TK or the Tinker library. And we are just giving the title to the GUI, and also giving the label, that is hard disk prediction system. And these are some of the function of that, like it will use this master tinker function and give a text to it, and also give a background that is black and foreground that is the upper part inside the black background to give it a 3D effect like black, and also we will create a grid system for that for like how many uh, rows it will be spanning, that is the row 0 it will be occupying, like the whole GUI will be split inside different rows and columns. So this hard disk prediction will be having occupation occupants of row 0 as well as it has the column span of two columns, means it will be ranging, it will be having a access area of first column and as well as second column. Now there are various labels that we are going to create. That is for age, for gender, for CP, for uh, trust, PPS, and other parameters that are there in the dataset, and assigning a dedicated row for it. Like it will be in a vertical column, having different label inside to it. The label part is just for printing the uh, entry, age, etc. Like if we will run the code here, you can just correlate with it. So here the heart disease prediction system is having a column span of both the first column 1 or column 0 and the column 1. So it will be spanning across the column 0 and column 1, and individual labels or this enter your age will be in the vertical fashion, this dedicated by row index 0, 1, 2, 3, 4. Until row 13. Then we will create input dialog box using entry function, that is a tinker function, and also place it across this tabular fashion. Like this, the GUI is distributed in a Excel format. Like if you will go inside the Excel and drag it out, if we just take these two columns like that, the hard disk is occupying these two columns, and individual this enter your age is in this row and this column. Like you can just see, take the P as column 0 and Q as column 1, and the right side part, that is the indexing, like 2, 3, 4, as the row index. Like that, the tinker is going to internally distribute this area of the GUI. And like here you can see, it has just placed each an element beside its index, and the button that is created here for prediction, and it is using a text predict, and also using the function that we have described earlier, show an entry field, and it will just call it from this button press, and it will just show the output in the lower half. If we will just use the text function from here, that is age is 52, sex is male, city is 0, and first ESP is 125 212 0 1 168 0 1.0 2 2 and 3. If you do the prediction, it should be no hard disease as this 0. And if you will just change some of the parameters from 168 to 304 and now test it. Okay, we have to again try the program. Now we will just select some random values like 72, 0. CP is near about 200. Ops is 120. Sorry, CP is 3. This 120, it is 200. 0, 1, 200, 0, 1.8, 3, 2, 2. If you will just predict positive hard disk. So like that, you can just create a hard disk predictor model for uh, getting an insight of a person, is he going to have a heart attack or not, any kind of heart disease or not. So any doubt till now? I will just share this codes with the team and also in the group, so that you can just go ahead and use it in your computer to just have a look at it. Also, you will be required to to install these pandas, as well as some of the library discussed here, like the sklearn, and also like the C1, and also the matplotlib, Tinker, etc. You have to install it inside your system. Otherwise, it will give you one error. Or what you can do is you can just install Anaconda, and, mostly used by the data scientists, data analysts, and machine learning machine learning peoples to uh, who doesn't want to install individual libraries inside the system to learn their machine learning models. It will some it will take some time. So here are some of the tools, some more tools that are used in machine learning, and some like AI in the development. So you can also have a look in the R studios, that is a R implementation. Like R is a somewhat other language than Python, and also some of the IDEs for Python, some like VS Code, PyCharm, etc. And Jupyter notebook, that is currently I am using for showing you the demonstration, and also some more like data spell used for exploring the data and doing some inside search. Some more are there, like you also need some data storage feature by using Oracle, etc. So any doubt? You can also chat if there is some doubt or anything that is not clear from the previous lecture, also in this lecture. Any doubts that you have right now? Might be my explanation is somewhat not that much to the point, because my English is not that much fluent. So is my audio audible? Okay. So anything, it doesn't have to be related to machine learning. Also, if you are doing some machine learning or any kind of programming right now, can you share the code, please? Okay. Are you in the group, that WhatsApp group? I will just share it inside that group if you want to go through. There are two more things that I wanted to cover, but due to time constraint, I thought it would be good if you can just go through it, and if you have done how to import and download a Excel file from Kaggle. The simpler way that I usually do is I go to Kaggle like that. and search for some. Wait a minute. Search for any random. Like I was working on creating hand gesture database. It is an APK file. Okay, sorry. Okay, we will go with the OCR. So here in that OCR, you can just hit here. Is there a data set here? There's no data. Okay, just we will go with the do this. And inside the hard disk, if we go here, and go to this one data set. Okay, here you can see that there is a data set here. You can just download here using this button, and it will just give you the downloaded data set. You will obviously need to be registered here. So like that. Also, if you are going to do some kind of image related work, what you can do is this is simple web crawl means a program that will just search for a uh, image that you have specified. Like if you will just it is a Bing image downloader. Simply, if you will just run it, what it will ask is the name of the photo. Like if I want to search for Elon Musk, sorry, Musk, and it will also ask for how many number of photos that you want. So currently I will just give it 10 and run it. It will go inside the individual website of the Google Bing search engine, and it will just download individual images from there one by one. So you can see that it has just downloaded 10 images, and if you will just close it and go where it is saved, everything. Okay, it has not saved here. Okay, it has saved here. So here it has created a data set, and inside that you can see 10 images of Elon Musk. Now what you can do is you can just take these 10 images and train the model within that the old teachable machine. Here you can just go inside that and you can just teach the machine like that. Anything else you want to know? Currently we have very few participants, so if each one of you want to ask some question, I will be able to answer them right now. Also we have 6 minutes more. Any random question, anything? Yes, if you want I can show you. There's this QR code, you can just scan it. If you want to ask me my social media accounts, you can just ping me there. Okay, after downloading the Excel from Kaggle, do we need to change the code or something to use its CSV itself? Like if we have a format like XCSV, like here we have a CSV format, you can see here a CSV format. It will be easily callable by using the, it is, if you go ahead, you can just call it using the read CSV file from here. If it is a CSV, but if it is in any other format, you have to change the read CSV to the format that you need. Like Excel usually save it in the format of Excel XS. 2 minutes. What it was? Hmm, whatever Excel file. Like it saves it as Excel SX. So you have to call it for that. Like if you will go inside the pandas library and just search the first link, and if you will go inside the documentation, you can go with the various things that uh, like getting start. It will show how to install the pandas, what all things you can do with the pandas. Like you can see the straight away the tutorials. Like in pandas, usually the data set is called as data frames, and how they are addressed and etc. You can just go with the documentation, just read. Like it can read all these kind of formats, like the CSV, like the HTML, JSON, XLS, etc. And it can convert also all the data frames into these all kinds of data. So you can just go browse, and you can just see how it is going to read pt dot read dot underscore CSV for you reading a CSV file. Also, there are a few more functions, like head will show the top five elements of the function. You can just read through the documentation. It will clear mm, approximately 90% of your doubts. Also, you can just copy the code and just run it in your local machine. Each library in the Python has its own dedicated documentation. Like if you go for Matplotlib, it has its own getting started, etc. You just go and see how the code are written, how you can visualize, etc.
So with this, our machine learning session has come to an end. So if you guys have any doubt, you may ask now, or you can either contact the speaker personally, or you can ask via the WhatsApp group. So thank you so much to the speaker, Nishant Roy, for beautifully explaining the concepts of machine learning. So thank you so much. Then a huge thanks to all the participants for, for their kind cooperation. And uh, a feedback form has been shared now on the chat box. So all the participants, please do fill out, based on which your attendance will be marked. And this event has been conducted by GDSC GECT in collaboration with GDSC GEC Wayanad. So thank you participants for your kind cooperation. The session has also been recorded. So the recorded videos will be posted on the WhatsApp group. Also, the code and PPTs will also be shared. So thank you so much. And please do fill out the feedback form.